This is Algebra 1, Unit 10, Lesson 1 on graphically representing data. So this is the first lesson of the unit on statistics. So we're going to be looking at statistical analysis in this unit. So we're going to start with putting data in graphs. So we're going to talk about quantitative data on a single variable is often collected in order to understand how a characteristic of a group differs among the group members or between groups. So when we ask a question like, how old is a typical fast food worker, it is helpful to take a survey and then see graphically how the ages differ among the groups. So the first kind of data that we're going to look at is what's called a dot plot. And it's called a dot plot for a reason. It's made up of dots. So in exercise 1, we have Charlie's Food Factory. He currently employs 28 workers whose ages are shown below on a dot plot. So answer the following questions based on the plot. So these are the ages of the workers. Every time we pick a worker, we put their age on here. So how many of the workers are 18 years old? Well, we would find on our scale here 15, 16, 17, 18. It would be this column right here. How many dots do we have in that column? We have 4. So there are 4 workers that are 18 years old. All right, what is the range of the ages of the workers? So basically we want to know how many years is it from the youngest to the oldest. All right, how old is the youngest worker? Well, the lowest dot that we have on here is at 16. The oldest worker we have is right here, and this will be at 42. So the range of the ages is from 16 to 42. That's how many years? Well, if we take 42 minus 16, that is going to be 26 years. So there is a 26-year range between the oldest and the youngest worker. Okay, so the next thing we want to talk about is symmetry. Would you consider this distribution symmetric? All right, now a symmetric distribution would look like it has a bump in the middle. It would look like this. All right, that is symmetric. Okay, so it kind of clusters around the center and it's kind of even on both sides. All right, so would you consider this distribution symmetric? Well, if I go like this, there's my ages, and then it kind of flattens out like this. Does this line look like this? No. Okay, so this is the area or the data is concentrated to one side. All right, so this is not symmetric, but it is called skewed. All right, and this is called skewed to the right because you look for the tail. And the way it's skewed is skewed to the right. So when your data is clustered to the left or to the right and making a bump and the tail comes out, that is called skewed. If it came up in the middle and then came back down kind of evenly, then that would be symmetric. Okay, now the mean or average age of the worker for a worker is 22 years old. Why is this average not representative of a typical worker? Okay, so let's find 22 years old on this data. All right, 22 years old, 21, 22 would be right here. All right, that would be 22 years old. All right, so would you say, based on your data here, that the average worker is 22 years old? Well, actually, no. This would not be representative of a typical worker. No. Based on this data, most of the workers are younger than 22. Workers are younger than 22. So that is not typical. All right, it would be a not typical of the workers. If you want a typical thing, you'd probably want something that falls right around the center. What would maybe the typical be? It would probably be maybe around, I'm saying 18, 19 or so, because that falls right about the middle of the data. So most of the workers are going to be younger than 22, so it is not representative of a typical worker. Okay, now let's construct our own dot plots. Pretty simple. A farm is studying the weight of baby chickens or chicks after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. construct a dot plot on the axes given. Okay, so these numbers down here are the ounces that the chicks weigh. So all we have to do is take each weight and put it on the plot as a dot. So at 2 ounces, we'd put a dot. 1, 3, 4. Now we've got 2 2s, so I'm going to add 2 more 2s here. Then another 3, a 1, a 5, another 3, 2 4s, another 5, a 6, a 3, an 8, which would be down here, a 5, I'm going a little crooked here, a 4, a 6, a 3. Okay, so our dot plot should look something like this. All right, now do you think this is symmetric or is this skewed? Does this kind of go like in a bubble? Let's see. It goes up and then it comes down. Do you think this is symmetric? Yeah, this is a symmetric pattern because it kind of goes up and then it comes down kind of evenly. If we drew a line of symmetry right here, it would look kind of even. Not exactly, but it's pretty close. Now all the data isn't squished to one side or the other, so we should be just fine. So that would be a symmetric pattern for the data. All right, now let's look at another kind of pattern for a data. We see this as a graph of a histogram. You may have done this in science class possibly, or other classes too. The following histogram shows the ages of workers at Charlie's Food Factory. The same one we just did in the dot plot, but in a different format. So in this one, how many workers have ages between 19 and 21 years? Well, what we'd have to do is find the range 19 to 21, which would be this column right here, 19 to 21, and we want to count that up. So how many workers would that fall in? Well, this histogram goes up to be right here, which would be 11. So there should be 11 workers that are between 19 and 21. All right, now what is the disadvantage of a histogram compared to a dot plot? Okay, so if we look at the histogram, we can see between 19 to 21, there's 11 workers. But do I know exactly how many 19-year-olds there are or how many 20-year-olds there are? No. If I wanted to do that, I'd have to go back to my dot plot here and count 19 to 21. There'd be 3 19s and 5 20s and 3 21s. We can see, can't see exactly how many we have. So you can't see individual data. Individual data for ages, but you can see ranges. Okay, so does the histogram have any advantages over the dot plot? All right, it's easy to see certain ranges. See total for certain ages, or ranges, I should say. Okay, so if we wanted to say, for example, most of the workers are under 21, would that be true? Yeah, if we look at our data here, it's really quick to see 16 to 21, there's a lot of workers there. Or if we wanted to say that the fewest workers fall between 35 and 44, we can see that's probably, or 29 and 44, we can see that really quickly on there. So it's easy to see totals for certain ranges. But with a histogram, you can't see individual data. If you wanted to see individual data, you'd have to look at like something like a dot plot. All right, now let's construct our own histogram. So there's some parts of a histogram that you need to be aware of when you see this. What we use is called a frequency table that will help us figure out how many things in each range of the data that we have. All right, the 2006-2007 Arlington High School varsity boys basketball team had an excellent season, compiling a record of 15-5, 15 wins and 5 losses. The total points scored by the team for each of the 20 games are listed below in the order in which the games are played. So these are the scores of the games that they made for 20 games. So what we're going to do is we are going to count up how many fall in each range. Now, having to individually count them can be kind of tricky. So what we're going to do is we're going to put hatch marks in what's called the tally, and then we're going to count the tally up for the frequency. So the frequency is how many tally marks you have. All right, so let's go through this. 76, right there. 55 falls there. 76, there. 64 is there. 46, 91, 65, 46, 45, 53, 56, 53, 57. All right, now this is going to be the fifth one, so I'm going to make a slash across like that. 67, 58, 64, 67, again makes a 5, 52, 58, and 62. Okay, so I have marked all of them here. So now all I have to do is count up my tally marks. So between 40 and 49, I have 3 tallies, so I have a frequency, 3 fall in that frequency, or in that range of scores. 50 to 59, I have 8. 60 to 69, I have 6. 70 to 79, I have 2. I have none between 80 and 89, and only 1 between 90 and 91. All right, so if I want to complete my histogram for this, I want to construct this on my table. So what I need to do, first of all, is to mark off each of the range's scores. I'm going to use 2 blocks each when I do this. So let me put this down here so I can see it. All right, so my first block that I have is going to be 40 to 49. So that's going to be from here to there is 40 to 49. Okay, now 50 would be the next number in the group. That would have to be between here and here. And it's got to touch because 49 and 50 are right next to each other. All right, and then I go on to the next one, 60 to 69, 70 to 79, and then 80 to 89, and 90 to 99. And I've got all of my sections done. All right, now the next thing we want to do is do the frequency. All right, let me put these down here so we have them. This was 386201. Okay, so what we need to do is mark off our scale here on the side. So this is the scores, and this is the frequency, would be this y-axis. All right, so we have to go from 0, which is down here, up to probably at least 8. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to go up to 10 right there so it fits. All right, you can number into each one of these individually if you want, but this is enough so I can see what I'm doing. I know that each one of these is going to be 1. All right, so all I have to do is take each frequency and plot it. So 40 to 49 is 3. So I go up to 3, which would be right there, and I draw a line across and then a line down, and I can see, I like to fill it in like this so I can see it. All right, so there's 3. All right, 50 to 59 would be these 2 blocks. It would go up to 8. So 10 is here, 9, 8 would be my line across there. This would come down. I make a nice bar, and then I color it in like so I can see it. All right, 6 would be the next one. There's 6. Fill it in. You've probably done this in science class before, so it's not a big deal. 70 to 79 would be 2. Right there, fill that in. 80 to 89 is none, so I don't make a bar there at all. And then 90 to 99 will actually be 1. All right, so there is our histogram. So we can see on here very easily, it's a good way to show data as a histogram, or you can also do individual data on a dot plot.